So we define the connected sum of two surfaces. So you have surface S1 and S2, and this is how you define the connected sum. So this is the symbol for connecting surfaces S1 and S2. So you start by taking a disk out of S1, then you take another disk out of S2, and then glue the boundary circles of the disks. So you take the boundary of the disk and you glue them. So let us see the example of torus and a connected sum with torus. So you have a torus here, you have a torus here. So first you take a disk out of this torus, then you take a disk out of this torus, and then you glue the boundary circles. So we glue these pink circles together and we get a 2 torus. So this you can say is 2 torus. So similarly you can glue more and more torus to it to get a n torus. So you can continue this procedure to get a n torus. Now let us see this in a planar diagram. So this is the planar diagram of a torus. Side A is identified with side A, side B is identified with side B. So these are two torus. Another torus is C identified with C and D identified with D. So now we will cut holes in these two toruses. So first you have to align these torus according to proper orientation. So you see this A and the C point in opposite directions. So we have aligned them so that their orientation is right. Then we cut circles in them. So cutting circles mean that you cut this portion out in the first torus, and in the second torus you cut this portion out. So the inside is the disk and this pink is the boundary of that disk. Now you glue them together. So once you glue them together, this is what you get. So this is the gluing part. So this pink is the gluing part. So you have glued them. So now you can see this is how it will look like. So to see this, say you have this big pink dot here, we'll put this pink dot here. So A goes into it, so A goes into it, then B goes into A, so B goes into A, then A is going away from B. So at this vertex A is going away, so this vertex A is going away, and then B is going away towards the line. Similarly for C, C is going into the line here, so C is going into the line here, and then D is also going into the line here, so D is also going into the line here, and then C is going into the line, D is going into C, so you can see D is going into C, and then C is going into D right here, so this C is right here. So you can see we have properly preserved these arrows. So again, now you can cut a circle here like this, and then you can glue this to here. So this is the proper orientation. So if this is this way, then the torus you will glue has to be this way. So you can get another this polygon with the 12 sides now for 3 torus. So this is 2 torus, it has 8 sides. So this is 2 torus with 8 sides, and obviously if you make a 3 torus you will add 4 more sides which will have 12 sides. Now we talk about another connected sum. Projective plane connected with projective plane will give you Klein bottle. So you have projective plane, so this is projective plane. So notice that A and A are going in opposite directions, and this B and B are going in opposite directions. So you cut a disk out here, and then you cut a disk out here. So again glue the boundary circles. So once you glue them, this is what you get. So A and B. Obviously A is going into A, B is going into B. So let us glue them. So once you glue them, you can again cut out a boundary circle and attach another RP2 to it to construct 3 RP2 and so on. So this you can say is 2 RP2. So then you can construct 3 RP2, 4 RP2, so on. You can just cut a circle right here and then glue this part to whatever you cut right here. So once you have glued, we will forget about this edge and then we will cut it right in the center. Now we cut it right here. So once you cut it right here, so say this edge is C, then you take this triangle and keep it right here. So this triangle is same as this one. So the bottom one, you can see A is going here, B and C, everything is same. Now we take this B and we glue this B to this edge. So you glue them together, obviously taking arrows into account. So say the tail is right here, so this tail goes right here. So A is going into this tail, A is going into this tail, and the C is coming into A. So C is coming into A. So now you have this new figure. So you have glued B together. So now let us erase this B. So what we have is a Klein bottle. You can see A and A are going in the same direction, and then C and C are going in the opposite direction. You glue A to A and then you twist to glue C to C. So these are going in opposite direction, so you have to do a turn. So you get a Klein bottle. So this K stands for Klein bottle. So you take two projective planes, take their connected sum, you get a Klein bottle. Now we talk about another important thing. You take a projective plane and then do a connected sum with a torus, you get a projective plane connected with a Klein bottle. So let us see this. So say you have this figure. So this C going into each other, this is your projective plane. So this portion right here below here is your RP2, and then above here is the torus. So you can see this is a torus. I mean, we can redraw it. So this A, say, is going like this, then B is going into it. So this B is going into it, then A is pointing in the opposite direction from the tail, so this tail is right here. So A is going right here, and then B is going away from A. So this is the top portion. So this looks like a torus. So this is a torus. Now we do the first cut. So we cut here and say we call this edge as D. So the rest of the portion we keep right here. So this portion comes right here. B is here, A we keep, then D we keep right here, B is here, and then we glue around C. So this is glued to this edge. So this is glued to this edge. So focus on this vertex. So this vertex, where does this go? So obviously it is the head of this arrow. So this will go right here because you're gluing C to C. So this will go right here. Now we need to focus on this. So in this vertex, what is coming in? A is coming into it. So A is coming into it. And then what is coming into the tail of A? D is coming into the tail of A right here. So D is coming into it. So you have glued it. So once we have glued it, you forget about C now, and we rewrite this as this. So you redraw it. Again, you have B and A, B, A. As such, D is right here, then B is right here. We have glued along C, so we have forgotten about it. Now you have D right here, and then you have A right here. Now we cut like this. So you cut in the center E, and you keep this portion right here. So this portion you keep right here. So that is this right side. You keep here. So you have E as E, you have A as A, then you have this B coming here, and then you have this D coming right here. And we glue this A with this A right here. So to glue it, first we have to say choose one of the vertices so that to keep track. So say this is the head. So this is the head which it is getting glued to, and this head is right here. So this gets glued here. So focus on this dot now. So what is going out of it? So we are gluing this side, so what is going out of it is D. So D is going out of it, and then in the head of D, B is coming in. So B is coming in, and then at the tail of B, E is coming in. So at the tail of B, E is coming in. So this is right here. So now we have this. You have glued along A. So now again we rearrange this. this E and this E are right here, this B is right here, this D is right here, then this B is right here, and the final D is right here. So this is your RP2 connected sum with Klein bottle. So you can see this. So this is RP2. So this is RP2. So E is going into E, and the rest is your Klein bottle. So this B is right here. Notice the direction of arrow. Then D is going into it. D is right here. Then this vertex is right here. So B is pointing out of it, and then D is going like this. So now you can see both D's are in the same direction, B's are in the opposite direction. So this is a Klein bottle. So this is an important result. So you have already seen this Klein bottle is equal to the connected sum of this. So this is equal to, then instead of Klein bottle we are going to write this result. You have RP2 here and then connect it with RP2. It seems like we are cutting at will, but whatever we cut, we glue it back. So there is no essential cutting, we are just rearranging things.